add to this computer, and here we go. All right. Welcome to the Virtual Production Academy. In today's class, we're going to be reviewing Blueprints 3 or Procedural Content Generation, or, how they are called really PCGs, right? So PCG is a technology that is fairly new. It's still, I think it's not experimental, but I think it's either alpha or beta status. It is an actual external plugin that you need to enable on your project. It might not be enabled by default because, again, Epic doesn't tend to enable plugins by default that are still either in experimental or alpha. Sometimes it will actually let them on by default if they are beta, but not alpha, right? And there is still, so much that there are that I bet that they have planned for PCGs that we're just barely taking a peek into what this system can actually provide. Today, we're going to be using it mostly to do some scattering of vegetation, like rock, bushes, and trees, and all that. And we're going to try to do something that is reusable. So, in many cases, between today's and tomorrow class, I want to create a few tools that you're going to be able to keep using and improving in time. That is the actual goal after these particular couple of classes, right? So we're going to be talking about the editor. We already went through a little bit of the editor, of the PCG editor. So we're going to straightforward go in and talk about the basic spawner. We're going to be talking a little bit more about the samplers and the density filter, how to transform them, and how to assign a particular mesh to be grown in those particular samples, right? But then we're going to start doing a little bit more of customized work for our PCG because we're going to start using splines to actually do a couple of things, creating zones where the actual PCG should be actually working and zones where you want to actually eliminate, that PCG. And we're going to be talking about two particular um, um, nodes that are called intersection and difference. So we're going to be doing some booleans, right, inside the actual PCG. And and then we're going to be talking about landscape interaction, how it can actually read out information about your landscape. Mostly, it's going to be about um, the layers, right, the painting layers, and how we can actually make them good use to force our PCG to obey, right, in terms of where it should be growing and where it should not be growing. And later on, we're going to be talking about PCG optimization, which is going to be mostly about how to control how far we want those PCGs to actually be produced, and the PCG nesting. So we can actually grab PCGs and set them inside PCGs, and that is going to be the end of this class. If we still have a bit of time, we can start with tomorrow class, which should involve two things. And that is going to be to I want you to learn how to actually make them very reusable. So you're not hard coding anything about them. So if you need to actually add like different set of trees, different set of rocks, you can do it from outside the PCG. So you don't have to actually edit the PCG for it to work. It's going to be mostly you drop the volume into your scene and then you assign the actual meshes that you want them to be, distributed around. And the other thing is going to be exposing some of the variables like density and the density filter, so you can actually tweak it from outside of the PCG editor. And yeah, there is one last trick that I want to teach you, and that tomorrow is going to be fun, and that is to use level instances as the source of meshes that you can actually use on PCGs, and that is like a very nice technique because it really rounds up what the level instance can actually do. Because the level instance, the only bad deal about it is that there are statics and that there are instances of each other. So if you make a bit of a tweak in one of the level instances, that is going to be true for the rest of the instances. So when you combine them with PCGs, you can actually have like small tweaks and differences between level instances, and that is really powerful. You're going to see that one. You're going to be enjoying a lot. So here we go. Let's actually do a bit of a fast review of what we learned already about PCGs. So let's go with the basic spawner, right? So let's actually come here. Let's say no. Let's go here. Let's create a new folder. Let's call it PCG. And all right. And let's create a new level, right? Let's actually come here, Control N, new basic level, kill the start. And soon enough, that's it. We're going to be saving this map into our PCG folder. And this is going to be called PCGs. All right, very good. So now we can start. So first thing first, you need to make sure that you have PCG support for your project, right? And that is going to be done by going up here to edit, go to plugins and search for PCG. And I don't. Oh, I do. Sorry, I do. The one that we're going to be using, the one that you only need is this one, the Procedural Content Generation Framework, version 0.2, the one that says beta, right? This is the only one that you really need. Now, if you want to do some other stuff like connecting it to the um, level instance, then you need this one. That is called the Procedural Generation Framework External Data Interops, right? So for today's and tomorrow class, we're going to be using just these two. Make sure that you have these two enabled in your project, and that is going to be a-okay. If you, as soon as you let them on, really it's going to ask you to restart, but it doesn't involve any sort of shader compilation, so it should be back on very soon. And that is mostly it. I'm going to be switching my scalability to high here. So we have global illumination back on. That is good. And let's create our first PCG right here. So PCG is really easy because, it is not like Blueprint where, by the time that we start learning about it, it has dozens and dozens, if not thousands of different nodes and application. It is really complex. PCG is very early in development, so it's really cool to actually jump in the bandwagon of PCGs, right? Because right now we have just like PCG graph instances and PCG graphs, and yeah, there's nothing too crazy, right? So let's start with the easiest one, right? Which is the PCG graph. Let's create one of those, and let's call this one. Let's call it sampler, right? This is going to be my PCG underscore sampler. We're going to learn about sampling here. And that's it. Now, we learned before that the PCG doesn't have an actual viewport on its own. So you need to actually use your viewport as the PCG viewport. So for that, we are going to need to double click on the PCG sampler, right? To actually uh, work with it. But at the same time, we need to drop it into our scene, right? To actually see what it's going to do. So we need to do those two particular jobs. Now, you may, realize that my size of PCG is not the same size as yours. And that is because you can actually change, as many of the different assets from Unreal Engine that you can create in Unreal Engine, they can become actors as soon as you drag and drop into your scene. So this thing grabs a PCG asset, and as soon as you drop it into your scene, it creates a volume, right? And this is what the actual PCG actor is, right? But it comes with a particular size, and the default one I have always think that is very huge. So right now it is 555. It comes by default 25, 525. Oh no, 25, 25, 5. So it goes into a little bit big. And when you start playing with PCGs, you might want to have them as small as possible because you're going to be drawing tons of data inside here. So if you want to actually control how big this thing is by default, you need to go edit project settings And in the project settings, you search for PCGs, or you can actually go down on the actual plugins. And inside plugins, you're going to have one for PCG. And here you can actually set how big you want that original volume. As soon as you drag and drop the asset into your scene, how big that actor is going to be. So I set it myself to 555. Normally it's 25, 25, 5, right? So, that's the only reason why it's a little bit smaller here. So that's good. Now we have, our volume of the PCG placed into our scene. It is actually intersecting this floor, and we are kind of nearly done on the preparations. We need to do one more thing, and that is to remember that the engineer who created this particular scene, the default scene with lights inside Unreal Engine, doesn't have collisions, and we need collisions on this floor for these to actually work. So make sure that you select your floor and you go until it says collisions in the details, and what it says, where it says collision preset, turn it from block all dynamics. You are going to reset the value to block all. So now you're going to have a floor that actually have collisions, and you can start making some data and samples on top of this floor. All right. So we're barely there. All right. So the first thing that we need to do is actually do some sampling. And I actually learned what was the issue before. They actually changed the sampler node, the surface sampler node. Now it doesn't actually, it cannot read itself. So it used to be the case where it actually will know. So input, if you open up your input in, this is you, right? This is your volume. And now the surface sampler said, you know what? We're going to have a new volume sampler, right? So you use that when you want to refer to your volume. And we are now creating a new surface data that you can actually query. So the same as you can create the landscape, get landscape data, right? And what this is going to do is give you like a separate input where it's going to say, well, it's not the volume, it is the actual intersection from the volume and the landscape, right? So this is what is going to be spit out from here, right? Well, there is a new one for these that is called get surface. Um, is it like that? It is surface. Uh, mm, data. Give me just a second. It is a get. So let me type get primitive data. I think it's this one. Let me try this one. I think it's this one. All right. And from this one is the one that you're going to be connecting your sample surface or your surface sample. So surface sampler. And let's see if this is the thing. It should be like this. So no, it's not. Sorry. Then let me do this. So get actor data, landscape, point count, primitive, spline. Huh. Oh my God, I did this yesterday. I was trained for this. Give me just a second and I will find it. Is it actor data? No, it's not. No, it's not actor data. Oh, I remember. Yeah. No, it's silly. It is, um, it's not collision, is world raycast. I think it's this one. No, it's not the world raycast. It's the other raycast. Like this thing now needs to actually project a ray down and actually find the collision for it to work. So it's not the raycast. It's the world ray hit query. Oh, this is the one. Sorry about this. I don't know why I thought that it should be like get surface data, but it was not it. It is world ray hit query. All right. Whew, first crisis averted. So what this thing is doing is actually from the top of this volume is casting a ray down, and that then is going to be hitting some surface underneath. And the nice thing about using this world rate heat query, instead of using like the landscape one, is that the landscape will only work with landscapes. This one that is called world rate heat query will hit anything that happens to have um, a colliding body on it. These will get evaluated, and that way is really easy. You have actual filters. So if you want to say like ignore other PCGs, or it has a bit of you can actually have like tags for it, so you can actually discern what you want this to be um, sample on. But for the most time, you want it to be hitting everything. So, for example, what I wanted of these is that no matter if it is a surface or if it is a landscape, it will actually be producing these samples, right? That is what we want. I'm going to make this just a tad bigger so we get a little bit more samples in. I don't want it to be huge, but I do want to have a couple more samples in.
What if I don't like following along here? What if I don't see the samples? What did I do
Oh,
wrong, you think?
all right. This is it. Um, Another thing about PCGs is that you need to be constantly debugging them because you need to ask it to show you what is happening at any particular place in the graph.
Okay.
So you're going to need to go on Surface Sampler, select it,
Yeah.
and hit
Yeah.
D to debug it. And then it's going to be
Huh.
there for you to actually see the samples.
Copy.
The crazy thing about this is that you're going to have to then stop watching these. So if you continue adding more nodes, you need to stop watching this one to see the next one, because you can actually debug two different states of the same graph at the same time, which can be really deceiving. For example, if
Okay.
you add something like a transform point, right? And if you are debugging this one, you can actually come here and start saying, all right, I want this thing to start rotating everything from 0 to 360, and you're not seeing the difference.
Yeah.
It's because you are debugging the wrong one. You're debugging, the prior step. And you could also go and debug them both. And now you have a bunch of stars, and you're like, what is going on? And that is because you're now debugging both at the same time. So you need to stop watching the prior step to actually see the next one. So
Okay.
you can see that there is tons to be actually be perfected about PCGs. And this might be one of them, the things that they might need to find a way, like having like a debug the last node in the stream. And that would be like a check up here. And then you will know that the last thing that you connected is what you're going to be seeing here. And if you want to, you could go and debug something in the middle, right? That would be perfect. Like it happens normally for materials, right? So you're going to have
Right.
like a end node that it could be a debug node. That would be amazing. That you will connect it to that thing, and that way, maybe there it is. Oh, there is. These guys actually have me bug. They have a bug in my house. Like every time I say something that actually make it reality, there is an actual debug node that you can connect it. So now this is going to constantly be debugging the last thing that you do.
Oh.
So it's very practical. All right, that is not that bad. All right, so there is an actual debug node that you can set up at the end of it, and now you don't need to go and start doing this kind of thing. If you want to stop this debug from happening, you can disable the node by hitting E, and then you can go and actually debug something in the middle, right? If you want,
Oh,
and then you
cool.
can let these on at all times. All right, I learned something today. That is really cool. We're learning together. All right, give me a second. All right. So the transform point is great. We have now a little bit of offsets in the rotation and everything, but what I'm going to do is I'm going to turn this off for now. I'm going to hit E. It will disable um, the node momentarily. So I'm going to put it there aside. And I want to keep doing a little bit of something with the surface sampler. So this is good and all the fact that it will try to give me like spread out samples, but I would rather use the data. I think that the data is more intelligent because I don't know if you notice, this thing has patterns. It's not fully random, or maybe it's so random that it actually create patterns. So you can see that there are like dark spots. If you squint, you will actually see that there are like some islands of dark spots here and there. And those are the ones that you want to um, use in terms of creating like small groups of things that are going to be spawned, right? Because you don't want like total random stuff like a rock here and then a bush here and then another rock here. You want to have like small islands of things, right? Like small islands of of bushes and then a couple of rocks in a group here. That is what you want. So for that, what I'm going to do is I'm going to select my surface sampler and I'm going to set to 0 the looseness for now. And now it's going to be like a kitchen floor, right? Like a tile kitchen floor. And I want to actually add more density to this until I found it. Like you can go, all the way up with this because it won't produce more samples than that they can actually fit in, elbow to elbow, right? So this is fine at any point. This actually has math to it. Remember that, for example, if let me show you. I'm going to set these as it is normally, right? Like 25, 25, and 5. So that's it. Let me actually grab everything lighting wise and I'm going to sync it under the rook here. So I will not see those, and I can actually watch all these samples at the same point. Let me show you a little bit how this works. So right now, we have a 25 by 25 meters, right, volume here in the scene. And we have a 2 meter sample. And that is because the point extends. This is the actual size of the actual sample. Is measured from the center out. So that means that this thing is 1 meter to this side and 1 meter to the other side, each and every one of these samples. So if you actually set these to be 50, 50, and 50, now this is an actual meter cube, right? And you can actually see that, yeah, it's like, it is not aligned with the floor, but you can see that there are 1 meter. Now, what is great about this is that if this is 25, I think that if you actually set these to be, um, let me keep going down. So as soon as you get to almost 1, it should be, I think 1 should be filling this completely. Because again, you're using a 1 meter sample and you're setting these to 1 square meter. If you set these to 1, that should actually fill up whatever size of a volume that you can actually get. So it will keep producing more and more until it's filled out. There is one missing here and there. So that is really weird. Maybe 1.1. Yeah, just for good measure, right? So what this is going to do is now I have 1 square of a sample every meter. That is what is provided here, right? So whatever distribution that you want to create from this, at least is going to have like a meter, from each other, right? Because you cannot produce samples over samples. And all right, that's it. This is looking very good. So what I want to do now is start, you can actually squint again, and you can see that these kind of create like small black islands, in this white ocean. And those are the ones that I want to keep. I want to see if I can remove all the white samples and keep the ones with 0 value, right? So for that, I'm going to be using a density filter. Um, Density filter. This is it. Make sure that you disconnect and connect everything again. And I'm going to set these to be 0 and 1. So now it's exactly as it was before. And what I want to do with these is actually remove some of the white ones, and I get more of the zero value ones or the dark ones, right? So now you can see that as soon as I start removing some, you start getting those little islands, right? Uh, Here and there that create patterns and like holes that are a little bit empty. So let's keep going it down until we get um, let's set these to be zero point 0.3. That's good. Now you can see that now we have like a good distribution. So if this was grass, this could be like a nice distribution to that grass, right? Now it still look a little bit squarish. So that's why we want to provide a little bit of randomization. And that is where the transform points come in. So I'm going to now on disable or enable these transform points. And now you can see that they are rotated now in different rotations all across. Now they are actually crossing, among themselves. And that is good. It's not that bad. So then we can convert these to be, I don't know, grass or bushes or whatever I want. And they're going to be overlapping a little bit. But, the fact that there are, in little groups is what we are after. But what we may want is to actually have some to be big, some to be small, right? That is what we want. And so let's actually do that by coming here and say, well, I want these to be from zero point 0.5 to 1. Now we're going to have some that are a little bit smaller and some that are a little bit bigger, but you can see now the distribution happening right there in front of our eyes. And lastly, what we want is to grow a particular static mesh out of this. And let's go about it. Let's go here and let's go mesh. And we need a mesh spawner. So far, so good. Now, this is where we need to actually realize that we want, oh, no, this is not the one. We need the mesh spawner. Mesh spawner. How many of these are? All right, there it is. Now we can actually put this there, and we can stop debugging. I think I can if I connect these. No, it won't debug. All right. So now that we got to the end where we have the actual static mesh spawner, let's actually assign a mesh here. So we're gonna go here. What it says, I'm gonna save just because, and I'm gonna save also my level. And I'm going to add a new array element. And from here, I'm going to go, um, no, this is not the one. Sorry, it's not in post process function stuff. It is on the mesh selector, mesh entries. This is the one that we want. So let's open this up. And here from the index, we can actually choose, maybe let's find grass. And yeah, let's put this grass. And that's it. Now we have a bit of grass growing in our mesh. Really easy, really fast, really good. Um, Now you can still see that there is a bit of a grid pattern, right? Because that thing is maintained from the actual sampler. So what we want is, let me debug the sampler so you can see what we're going to do. There is an actual looseness value here, and I'm going to add a bit of that. So what that is going to do is actually have a little bit of space between the samples, and now they're going to be like twist. And so they're not going to be like a straight line. Now you can see that they are crooked. And this is what we want. Now look how that actually changes a little bit how our the grass is looking. Maybe we need something a little bit more noticeable than this grass. Let me open the scripture here and let me choose something a little bit bigger. So maybe I remember that we were having issues with the BU. Remember? Yeah, if you search BU on the mesh list, it's gonna Unreal Engine is gonna crash. I can't believe that I may be the only one who is searching BU in the mesh entry. I was like, maybe I dream of that. Maybe that was a nightmare that you cannot search that term. But no, it's a crude reality for PCGs. All right, let's choose trees, and that is gonna be best. You know that I'm actually um, um, thinking that it's gonna crash. Um, because I save everything. All right. So again, let's go to the uh, mesh selector. Oh, I need to actually create a new one. I'm gonna choose tree. Yeah, it's gonna be better. It's gonna be really noticeable. And yeah, let's grab this one. This aspen tree looks really good. Oh, it's huge. All right, it's all right. Let's fix it. Yeah, I don't know what is this about, but fix it on real. That is good. Let me actually take a look at this. It is preparing shaders, so you know. All right,
Gabriel, what was
go
the
ahead.
node that you added at the other side of the transfer points? What was that again?
Oh, the mesh one. It's
Yeah.
called static mesh spawner.
Oh, okay. Yeah, I couldn't remember that.
All right. So this is it. Now I converted this to be, trees, and now it looks a
Uh,
little bit better. Now you can see the true nature, of the samplers and how they can create something that looks very, very good. Um, Look at that. It's not that bad. All right. So let's now we know how this works, right? Now we know that this thing we need to actually have like this role reg hit query where it's gonna be actually. I think that no, it's good. Like I was thinking that it may be a little bit synced down, but no, it's perfect. So we need to have this world rate hit query to actually project down the samples. Then you're going to be creating a surface sampler, and then you're going to be creating a density filter that will give you, how dense. You can actually cool out a particular end or bound end of the sample, and then I transform some of those points, and then we're off to the races, creating a static mesh spawner, and whatever you set this thing to spawn is going to be right there, right? The other thing that we can do with this mesh spawner is actually create and another entry, because yeah, we might want to have another type of tree here.
Hmm.
So here on the array element, I'm going to be creating a second array, and now you can see that now there are some empty spaces, and that is because we're using the same. Now we are dividing randomly in half the number of spawns, and now we want to add like another entity here. So in this case, it's going to be another tree. Let's go tree and here hill tree. What is this about? Let's see how this looks. All right, it's preparing the mesh. Let's give it a second, and very soon, let's drink some coffee. Mm. Oh, this is from the kite demo. There are some issues with these. I don't know. I should actually remove this kite demo environment from this project. Hmm. All right. I'm not going to be waiting for this. Let me actually kill it and yeah, and restart it. It's all right. Live and learn. All right. Give me just a second and it will uh, come back really soon. So we are in this one. All right. We are doing good time. All right. Yeah, open it back up and open my PCG level. Now we should at least have the trees. All right.
Yay!
Yeah, we're back at the start. Um let me add a second one, and I'm gonna make sure that I don't choose that tree. So let me choose another tree. Um this one is huge. There are two cave trees. Oh, wait, these are from the actual. Soul City. Oh, this is good. This should work. Yeah, yeah, yeah. Complain all you want.
I was watching a video of an artist using, he's like, I'm going to make a landscape, right?
Hmm.
And he just was using PCGs and tools, and literally in 45 minutes, he had this like pathway down a forest with a
Right,
deer up on the hill. And I'm just like, I hate you. Because he was like terrain sculpting tools, and he just really knew how to, use all these tools.
right.
But he just knew, he knew them so well that he just sat there and he's like, 45 minutes later, I
He
got
he
woods.
he
And
knew the pitfalls.
yeah, yeah. I was just like, oh my God.
All
It
right.
was,
So let's let's learn now about um, splines, because the splines is what is going to allow us to be more creative about this, because there is an inherent flaw about PCGs, and that is that they will go to the end of the volume and now they are square, and they're a horrible square. So we may want to have like a zone, right? And for that, we can actually use a particular node that is really good. That is called um, get spline data. This one right here. So what this is going to do, the same as the world ray heat query that is actually finding surfaces under it, this one is going to try to find splines that are also intersecting the volume, right? And it can be done by an actual tag or a name that you can assign to that particular spline. So what we're going to do is actually add a component tag to, because we're going to be creating more than one spline. So we want that to be the zone, all right? This is going to be the zone tag for this spline. So now we're going to be able to actually look for that spline. And then we're going to be able to sample it and do a bunch of stuff. But for now, we don't have an actual spline here that we can actually sample from. So we need to actually create it. For that, we are going to need to create a blueprint. And it's going to be a very dumb blueprint, because the only thing that it's going to be doing is going to be holding a spline component inside it. And that's everything that it's going to do. So we're going to be right clicking on an empty spot in our content browser, and we're going to be creating a blueprint class, and we're going to be creating an empty blueprint class. And these we're going to also call, zone. And we are going to be double clicking on that. The name is irrelevant. You can actually name it um, Pedro, and it's going to work the same. The one that you need to make sure that you have that tag name is going to be the component that we're going to be creating here. And it's going to be a spline. Here it is, a spline component. And this is how it's going to look on the viewport. This is good. But because we want it to be a zone, we want it to be close, right? So we're going to do like a close loop. And so with the spline component selected, we're going to close this loop. But it doesn't look close because it needs like more points. So we're going to grab the end of this and we're going to hold down Alt, and we're going to be, expanding this. So now it's an actual, zone. It is like a exclusion zone where you can actually assign these a particular size. And that is good. Uh, Maybe what we may want out of this is for the actual spline to be in the middle of this instead of being like in the corner of it. So just for fun, I'm going to be doing this. So now, the center of the blueprint kind of is the center of the zone, which might be fun to actually see. All right, that is really good. The nice thing about using spline components is that whatever shape and the number of points that you have here, you can actually edit it outside of a blueprint once you actually drop it into your scene. So you can have different shapes of this zone. Now, what is important is to actually search here on the details, on the component, on the spline components, and we need to search for tag. And in this case, instead of creating an actor tag, we need a component tag. We need to actually assign a name and a last name to this thing so the actual PCG can find it. We already are asking on the other side, on the PCG side, for one particular spline that is called zone. And that's it. we can hit enter and we can save this and we can close this. And that's it. This is what we want, right? Now, sorry, give me just. All right. So that's it. Now we can grab this zone zone blueprint, and you can see that, yeah, it is a little bit tiny, but it is here. So I'm gonna be grabbing, a couple of these and making it just a tad bigger, so we can start using it. All right, this is great. And the other thing that we need is for it to be actually be inside our PCG, and that's it. Now it's there. Um, So for now, what I'm going to do is I'm going to be saving everything, jumping into my PCG, and I'm going to be hiding these static mesh spawner just for now. So I'm going to be hitting E, so I can disable, because now I'm going to be working on a different stream of our PCG. So I'm going to start doing a sampling for these, not for the floor, but for the spline. So for that, we're going to be stretching from here, and we're going to search for spline, and we should have a spline sampler. So that's it. Let's see how this looks, right? And we can actually connect these to our debug, maybe, so we can actually see it at all times. All right, so that is that. So let's select the spline sampler, and you may not see it, but right now it's actually, oh, wait, it might. So is it, oh, wait a second. It's not airing out. So are you actually finding the by tag stuff? So I think it is, because it's not airing out down here. So my guess is that it's actually finding that. Now let's see if we can actually make it happen here. So by default, this is going to try to do like a sample that will follow, the shape of the spline. That is not the one that we want. So instead of the dimension being on spline, we want these to be on interior. And now I know that it's not working. So why it's not working? Get spline data. This is good. Include children, maybe? No. By tag, it's zone. Maybe I actually set misspell zone here. Tag. Oh, it's actually zone. No spaces, no nothing. It is zone on this side. Yep. So save and save. Hmm. Right. Let me try and see what is going on here. Yeah, it's on interior. Get spline data. Oh, all right. Yeah, this is it. In the actor filter for get spline data, it's actually trying to find. Um, so, lately they actually added um, an actual node from which you can create these splines. I don't like to use them because I love their reusability. So I want to add as many of these zones that I want. So it's trying to find it on, inside the volume, but it's not inside the volume. It's an external spline. So here, what it says actor filter, instead of self, you need to set all world actors. And now these should start working. Mouse overlap, select multiple, tag. Oh, all right. Now it's asking for a tag here. So here is zone. And will you find this at some point? Maybe I need to move it around. Hmm. All world actors. Oh, this is an, oh, all right. This is an actor tag. And this is the component tag. All right. So Let me try this. All right. So all world actors by class, by tag. All right, let me do this. I'm going to assign an actor class also to the blueprint zone. So let me see if these actually fix it. If it fixes it, um, actor tag, let's call it also zone. It's all right. It could be the same. Oh, now it works. All right. So let me fix this on the actual blueprint. All right. So let me reopen the zone stuff. So my guess is that now they require, an actual tag for the actor because it's going to be a little bit more optimal. So instead of looking for all actors, it's actually finding actors with a particular tag. So I'm going to be reusing this zone tag for both the component and the actor. The tag on the actor, you can actually add here in class defaults. Yeah. So I'm adding both zones as a tag, so both in the actor and in the component, just because the actual PCG asks for it. So the actual get spline data needs to actually find a particular actor with a tag. This is new. There was a point where it will actually search for all world actors and be done with it. Now you have this differentiator, which could be nice, optimization wise and in order wise. This is a little bit more direct, right? So now this gets blind data is actually asking for a particular actor that is called zone that happens to have a spline actor in it, and a spline component in it that is also have an actual tag called zone. That is good. We are getting there. And now, because it's actually finding the data right here, you can actually then create a sample of it. And now you can, what we want out of these is to actually have like a good encompassing, shape. So the actual size of the sample is going to be important. The value is not important in this case. We want it to be, I think this is pure white, so it's one, and this is what we want. So what we are creating here is a mask. It's really what we're after here. So I'm gonna be setting these a little bit smaller, so maybe 20. So now you can see that it is a little bit more dense, and now it's encompassing much better the actual shape of this. Maybe 2020. Ah, that's right. So now you can see that it is actually kind of the shape of my spline, and it's a white mask that I can add on top, right? So this is what I'm after. And if I at any point, change the shape of this thing, it's going to create more samples to actually have the particular shape. And I can actually add more points to this shape. And now it's going to keep on, creating more of these samples in. So now what we have here is an actual mask. And now um, we have an actual surface sampler that is the base for our trees. And we have a mask, right, that we can apply to this. So this is what we're going to do now. We're going to be using something that is called intersect. And that is like a Boolean that you can create. So intersect, intersection. Here it is. So you have a primary source, which is going to be the base. And we have a source one that is going to be what we're going to be intersecting with. And now from the result of it, then I'm going to be doing the rest. So we can actually start debugging this. So if we actually check out how this looks, um, like this, now you can see that this is the full value of my surface sampler. And then if I actually check out this one, I'm going to be turning off these and actually checking out these. Now you can see that with this mask, I can tell this sampler to just show what is intersecting, right? So the white mask is intersecting with the base surface sampler. And now the rest of these is what is going to be then, density filter and then transform points and the rest of the rest. So the actual point at which you actually create this is, your own. let me check how it looks here, or maybe I'm going to have to do it a little bit further into this, but let's see what we get out of this. And I'm going to stop debugging my mask because it is actually good. This is a white mask with the shape of these. Now, if I turn back on my trees, voila, this is what we get. So this is it. If I actually grab this PCG zone, sorry, this blueprint zone, and I delete it, what we're going to get is an actual empty PCG because there is nothing intersecting with the original sampling, right? So the good thing about this is that now I can give it the actual shape that I want. I can actually drop one of these zones in, and now we're going to have a couple of trees growing there. Now I can grab these, and we can actually extend this and say, well, I want the actual shape of this PCG to be exactly this. And maybe for this to be a little bit, better in terms of reusability, we want this zone to come out a little bit bigger, right? It's hard to actually judge how big this is because we don't have anything in context. So what we're going to do is actually add a bit of space, just eyeballing it. So let me add a little bit of here, and we're going to be adding a new control point around here. And I want the actual center of the actor to be quite at the center. So this is good enough. All right, I'm happy with this. Good. Now I'm gonna save, and now I'm gonna drop a new zone here. That's it. Now I have a zone here that could be there, right? Now, what if I want to have another zone around here? Well, I can grab it and drop it here, and now I have another one. Now that is happening because in these get spline data, I have select multiple. If you don't have select multiple here, it's gonna only find the first one and then ignoring any other, um, coincidence with these actor by tag, right? So in this case, it's better to have it on because now I can have, different zones. Now, this zone will only work, right, if this thing it's actually intersecting with the original volume, and that is, really important. In fact, if you go to the actual surface sampler, it does have something that it's called unbounded, but that will not work with the world hit query type. If you actually use it for just specifically for landscapes, then you can actually make it unbound and you can drop like a tiny volume in the center of intersecting that landscape. And then you can hit unbound and then it's going to try to, fill up the full landscape at once. And then you can use these spline samplers and zones, right, to actually tell where you want this thing to actually be growing from. So what is great about this is that now you actually get rid of one of the biggest issues with the PCG, which, yeah, it is the fact that it's square, right? Now you can actually give it a particular shape to it, and this is really what you want. Now, there is one thing to actually take into account with these um, spline sampler. Let me show you what that is. I'm going to be turning off this static mesh spawner for a minute, and I'm going to do the debugging of the spline sampler for a moment. So you would be tempted to actually grab this and make it bigger like this, but you're going to see what is the actual issue. It will actually increase the size of the samples. So you're going to get like a jagged edge. So you may want to actually make it like really dense. So even if you actually make it bigger or smaller, you're gonna have, the same shape encompassing, the edge of this. But depending on the actual size, so if you make it huge, you're gonna see that now you're gonna have like a weird of a jagged edge because this now is a big sample that is happening inside here. So you gotta make sure, right, that you manage these with the so you can actually keep the size of your actor to be one, and you grow it by actually moving the control points. And this is going to be fine because if you move the control point, the PCG is going to create more samples and it's going to keep on encompassing the actual shape very nicely. But if you make the actor, if you enlarge the actor, then it's not going to create more samples. It's going to also grow the samples and it's going to start showing a jagged edge, right? So that is important when you're using this. All right, so now we beat one of the biggest issue here. Now it's not a square, but now I want to create a path that will go through these forests, right? Now the forest can have its own, shape, and that is really good. But I may want to have um, a particular empty spot, right? That could happen at any point. Well, for that, we're going to be doing exactly what we did here, but instead of intersection, we're going to use exclusion, right? So let's do that. Let's actually copy these two because these two were really good, right? Let's actually reuse them. What we must make sure is that we're getting now another name for the actor and the component. So in this case, this is going to be path, and it's going to be path or also here, path, path. That's it. Give me just a second. I was smelling smoke and I was like, something is burning. But no, apparently not. My wife has a much better sense of smell than I am. I used to smoke for 20 years, for more than 25 years. So yeah, I barely can smell anything. All right. So now we are reusing these two nodes, but on the get spline node data, we're now looking for a different actor with a different component section. Component tag. So that is good. So what we're going to do now is actually also reuse these zone stuff, right? So we can actually duplicate it. And this is going to be now path. And what we want out of these, let's save everything. We're going to edit it, the path, and it's going to look kind of the same, but we must do, the actual changes. Um, so what I'm going to do is actually I'm going to get rid of this spline and create a new one just because that one is not going to be close. Spline. There we go. Now you can see that is, here we go, is straightforward. Let's make it a little bit bigger because we know that we're working with, a very large place. So let's go and do something about there and then create another one there. And we can grab the center one and move it a little bit to the side. And then, we're going to grab this one and throw it again a bit like there. Now we have a bit of a path going on here, right? So these will go like this. Very good. All right. Now we need to change the tags. So first, let's change the component tag, right? So let's search for tag and let's add a new one. And this is going to be path. And no, it's actually smelling like smoke. Give me just a second. Amor, ¿me puedes cerrar ahí la ventanita, por favor? Porfa. Sí, me molesta el humo. Ah, no tenía tiempo. All right. Gracias, mi amor. All right, here we go. Here we go. AC full blast.
Is your cat on the balcony smoking?
Yeah, I thought so. It's been happening. Some weird stuff has been happening lately. We found a dead pigeon in the chimney outside
Yeah.
in the balcony,
Yeah.
and I had to clean it yesterday, and it was awful. That thing was putrid. So yeah,
Oof.
and now the smoke. Someone is smoking around here. Like never. I have never smelled, cigarette smoke around the house. But we live in a first floor, so anything can happen. All right. So now we have path. We actually name the component tag as path, and now we need to do the same with the actual blueprint. So this is going to be path, and that's it. Let's save this and let's give it a spin. Sorry. Let's grab our path and throw it there. And right now it's not going to do much. Oh, there is something more that we want to do here now that I realize. You can see that it's very thin, right? It doesn't have an actual, width of the path. So if you select your spline component, there is, where is it? In advance, maybe? Let me look for it. There is a way of actually having a width to this thing. Closed loop, no. Um, no, 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 no. Where is it? Duration? Nope. No, no. Mm-hmm. It's not a closed loop. Loop position is not that one. This is good. Oh, here it is. Scale visualization width. Now you can see that this thing also have like a width to it, right? And this is good. For now, we're gonna set it to be 100 because it's gonna be like a 1 meter by default. And if we actually set our sample to be 1 meter, we can actually match this thing with this width and the actual width of the sample. So let's do this. Let's save. And now if we go here, we can see that this thing actually have a width to it. And this is good. Let's save everything. And let's now go back to our PCG. And we must do a little bit more of math here, right? So this is it. This is actually erroring out because this get spline data is searching for path. So this is good. So what is happening here? Say what? Bounding shape on spline. So I think these should start working. So what I want is to have like it. We should start seeing an actual very thin sample going through the actual spline. Let me see if we can get to see that. So again, all were actors, path. Hmm, it seems to be good. On spline, I'm not seeing it. It is on spline. This is good. In distance. Oh, I'm very stupid. I'm not, I was not debugging the shape. So that might be the actual issue. Oh, now I can see it. It's very thin, very tiny. It's right there at the center. And you're going to see that it's going to be dropping a couple of those at a distance. And it has like many different modes. There is one that is called subdivision, and you actually assign like a number of segments per. Let me actually come here and unbug this. That's right. So in between control points, it's going to create according to these four subdivisions, right? So these may be good enough or not, depending on how you are, um, how bendy your path is, right? So for now, I'm gonna leave it at four. Maybe we're gonna realize later on that this may be a little bit coarse, and we need. You can see where it ends and it starts again. So the amount of swaying that I'm doing here is, yeah, it's not that. Uh, let's add, let's double this. Let's put 8. So now you can see that it now has more resolution to actually follow the shape of this. But you know what? It's tiny. It's very small. So for this one, we want to actually use what is called a bounds modifier. So let's add a bound modifier. Let's stop debugging this one and start debugging the bound modifier. And what we wanted of these is to actually set the scale because that is going to be the easiest. Right now it's 1, 1, so it's very tiny. Let's see if we can actually make this 50, 50, 50, and so now you can see that this thing is growing to one side of the to the right side of the path, 1 meter, right? And now let's do that for the other side. So it's going to be 50, 50, and 50. Oh, sorry. The minimum one needs to be minus 50, minus 50, and minus 50. Am I right? Yeah. And the bounce match should be 50, 50, 50. So now you can see that this kind of wants to encompass this thing, but it's not, getting to it. So let me actually make it a tight. I think it needs to be twice. So let's go minus 100, minus 100. And yeah, the height is not really important. It's not really, as important. So let's leave that minus 50. And this is going to be 100 and 100. And all right, now you can see that is quite the width of the actual path. So this is a nice mask already happening, right? So this mask is actually following this around. And now if you actually grab this and you make it a little bit, you know, more, give it more width, it will actually follow with the actual size of it. So this is what we want. Let's make it tiny and see the resolution of this. I think it's good. Is there are bunching up a little bit, but I think it's not that bad. Um, Maybe here on the um, uh, I I may think that these might have to do with how distance are the actual. We're gonna be keep playing with these. So for now, I'm gonna leave it like it is. Right? I think it's so far it's working. But now what we need to do is actually do our math here. So now, apart from the intersection, we want these to have an exclusion. Um, is it exclusion? Mhm. Oh, it's difference, not exclusion. Sorry about that. Difference. Very good. The source is going to be, first we need to actually make it appear. So we need to start from here, not from here. Uh, and then we're going to make it disappear, right? With the difference. And now, instead of going from here to there, it's going to come from here to there. Let's give ourselves a little bit more space here. And so far, these should be working. Let's see if that is the case. Let me start debugging this one, right? And yeah, it's actually happening. You can see that if I now start moving these around, I can make, you know, the actual original, the original sample to disappear. And now, let me put that there. Ah, yeah, you can see that if I actually make it a little bit more, longer, it's going to have these issues. So what this means is that I may need, if I keep on adding, at some point it's going to create like a new sample in between, and it's going to actually try to fix it. But we're going to have these empty space. So in the bounds modifier, I think that I need to make these also minus 100 and 100. Ain't that right? No, that makes it taller. Yeah, this is not what we want. So again, let me put this back as minus 50 and 50. So I think this is the actual number here of subdivisions per segment. So let me do 10. All right, that kind of fix it. So maybe subdivision is not the greatest. Let me see if I can set this to be distance. And then I think that if you fix the distance, no matter how many of these you actually do, am I creating more or less? Let me add distance. Oh, all right. So yeah, that's it. So let me see if I can find like a good distance on the spline sampler where it fits all shapes and all sizes. My thinking is that, yeah, 200, which is 2 meters, should be good. And now these should be working for any particular size. So it doesn't matter if huge. It's going to keep on adding more and more on a distance. So I think this is the ticket. All right, this is good. Um, So from the bounce modifier, you can actually make it wider, right, and taller. But the actual length of it, you assign on the actual spline sampler with distance and distance increment, because the actual size of a sample here is going to now be 1 meter by 2 meters by 2 meters by half a meter, or 1 meter tall, right? But the thing is that half of that meter is below ground. All right, this is good. Now, this has a fatal flaw. Let me show you what that is. Remember that I told you that I want this to work like everywhere, right? Uh, and right now, this spline, it's only working for a flat space. So let's say that I'm going to save everything. We have not taken a rest today. It's all right. Let's do like a 1C on this one, because there is a few things more that I want to actually get to. So let me actually do a sphere shape, and let's make it huge. Something like that, right? Now I can put it, around here. Now, as soon as I move my PCG, um, oh, this thing is, all right. So the fatal flow is even worse than I thought. So this thing is not projecting down, and that is, really bad. So why the hell this thing is called world rate query? It doesn't matter. We're gonna fix it. So this is what we want. We want these to be, projected down, and I think we could do that after the difference. So I think this is gonna be fine. So we can do it as late as down here. So what I want now is for this whole thing that now is fully flat to be projected down and follow, the actual, different shapes that you can add on the base, right? So for that, after the transform point, we are going to be adding world world ray heat query. No, this is not the one. Oh, wait. Why now are you kidding me? All right. What about now? Hmm. All right. This is actually doing some weird stuff. Hmm. It's actually projecting and then it's not projecting. It's weird. So let's see if we can actually make it work. All right. So it's the world. Oh, all right. It is the projection. First of all, we need to actually project it. Now, where we're going to be projecting it is going to be a projection target. And this is the actual ray. And I'm guessing is the world ray heat query. And set ray parameters. Yeah, this is the one. So what is weird is that it's the same one. That is so weird. But this one should be doing the correct thing. Let me see if that is the case. Are you or are you not projecting these down? Mm, this thing is not working properly. So this is pointing down, and this has a direction. All right. Let me see what is going on here. Give me just a second. So I'm going to do this up to this point. Forget about this. What if I grab this and make it like this? Will you Oh no, you're not projecting. So you're not kidding about that. It is actually doing it, but I don't know why I need to actually debug and undebug this thing. This is so weird. And why this sphere is not patience. Patience, Gabriel. Everything happens because of a reason. Right. Will you collide with this sphere also? If I move you around maybe, and then I debug and undebug you, it is all right. There is some weird stuff happening here. So let me try and see if I can actually make this actually work. All right. Let's go back as we were. Uh, I'm going to set these to zero rotation. Let me check out these and let me remove this sphere for now. So this is kind of working. It's actually being projected down, maybe. Let me see if that is the case. I'm going to be selecting um, this spline. So I will have to actually stop debugging it because it's going to be impossible for me to actually check this out. So if I select this and push it up, and then I do this again, yeah, so this thing is not projecting down. So we must make sure that this is always projecting down because you're not going to be producing the original samples on a flat space all the time. Sometimes you're going to have like a mountain or something. So you don't want to go and actually create a spline that actually follows the terrain. You want something that will be on top of the terrain, and then that thing is going to be projected down. That is what you want. So in this case, it's not doing it. So let's actually fix this. I'm going to be dropping this down as it was. And what I'm going to do now is to actually do a projection here and checking it here before we actually do the full thing. And then if it works here, we can move that logic up ahead. So again, what we want is an actual projection. This is good. And from this projection, we want to have the um, world, yep, the world raycast. And this thing, by it is not the world raycast, it's the other ray hit query. Yeah, this is the one. So this one, what it's doing is actually from each sample is projecting a ray hit, and by default is pointing down. Like you can actually come here and see the ray parameters, and it's actually starting from the center of the sample, and then it's being projected down. You know, this length, which is hilarious because it's huge. So this is good. So this should be actually working. Now let's see if this is working. I'm gonna be this is what I'm going to do. I'm going to grab the path, the full path, and I'm going to raise it, you know, like this. And what I want is with this projection is if I now go and check this projection um, like this. All right. Oh, now it's working. Oh, all right. All right. Now it's working. You can see that it is being projected down. It doesn't look quite right. So that is because this projection might be projecting rotations, and that is not what I want. Yeah, I want just to project positions. So, all right. So this is good. This is what we want. But we want this to happen for the full thing, right? To happen for the base. So, all right. Now let's see if we can actually make this work around here. So this is all debugging and see if everything is working correctly. So I'm going to be copying this like that. I'm going to paste it here, and I want to make sure that this is working. So I'm going to start debugging these. All right. And now let me actually set up some sort of shape here where these could be colliding with. I tried a sphere. I'm going to try a sphere again. these should actually work, believe it or not. So, all right, what if I now move you just a tad and you recalculate? You're not doing anything. Hmm. Hmm. All right. So, all right. So, why is this surface sampler now not working? Oh, for fucking real. You're really killing me, man. My God. All right. So I just got from an animation class that was really buggy, and I hate every minute of it. And now I'm experiencing the same thing with this. Yeah, they actually did a trick, a complete act with this surface sampler. It works whenever it want to works, which is a terrible way of actually working. Now you can see that it actually encompassing the thing without using the stupid projection node. So now it's working on this side, or kind of working, or at least how I would expect this to be working. All right. So that tells me that I don't have to use this. So this is nice as it is. Because
As a,
accordingly, go ahead, Matt.
I was just gonna say maybe as just a comfort or a virtual hug to you.
Mhm.
It is a beta plugin.
Yeah, but the thing with beta is that you would expect that it would be getting better every time,
Yeah, yeah,
but sometimes it get better. Or you know what? This is the thing. It was getting better. Like every time I open PCGs on each version, it was
yeah.
different. You need to, readjust a couple of notes and here and there, and things will change just a bit from time to time. But everything keeps working, right? Like the dude that is behind this was testing this stuff as he was doing it. But this time, I can't believe that, this is so hard. Like this, it's wrong. The fact that
Right.
I'm moving the PCG and it's not recasting this
Change.
thing down.
Right.
Uh, what if I hit regenerate? No, not even that.
Yeah.
Oh, you need to clean it up and then regenerate, and that will work. This is not how this should be working, or at least it,
Right.
it was not how it was working.
Was okay.
Um, so now you can see that you need to fight a little bit this issue. Like as soon as you move this should be actually be re. Um, maybe
Deforming
there is
to it.
something that I need to put here. Yeah, this is so simple. The actual surface sample, maybe the word in query, maybe there is like a. Um,
I think sometimes it's also the torture of you're in a real time world, but it's not
hmm.
really real time.
Yep.
Like you want it to just be like beep 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 beep, and it's yeah no.
It used to be like that. So I wouldn't ask for it to do magic,
Yeah,
but if it used to work good,
yeah, yeah.
it should keep working good. But it's,
Right, I
yeah,
agree.
it kind of is not. So
Well,
now we
well,
know that we need to clean up and regenerate every time
yeah.
we move it around. But
Okay.
it's all right.
Well,
So what I'm gonna
I call
do?
that Gremlins,
Oh yeah.
like the movie Gremlins. You know.
Yep. So what I'm gonna do is I'm gonna keep this projection node on the spline because yeah, this one is gonna be hard to actually implement if and I'm betting this one is gonna be automatic. Um, so let's try this. So this is good as it is. We don't need to add more to this. This is flaw, but at least we know that it will work if we regenerate the stuff. So we do the intersection with the zone, and now we want to remove part of it with the path. So far, so good. And from here on, everything seems to be fine. So I'm going to be debugging just this last transform point, and this is what we should be getting. Again, the projection node is actually projecting down this spline, so it doesn't matter. Whatever you need to provide out of this is at least higher than the detail of the surface below, right? So now I can actually grab this, and you know what? This thing is not growing on top of the. of the sphere. So you know what I gotta do? I need to select this, clean up and generate, and it's still not growing on top of this. Oh, I know why. Um, I know why. Because this intersection from this spline is not being projected down either. So we must actually provide a projection for this one. That is good. So I'm going to be copying this and pasting it here. Remember that this is the actual mask that produces um, the zone. And the zone right now is flush with the ground. So what we must do now is actually grab the zone and push it up. And then that is going to be projected down, if I'm not mistaken. All right, let's do a little bit of debug. So I'm going to be turning this off, checking out first. This is working. This is actually producing samples on top of the sphere, right? So now I want this projection to actually work, and this one is not working. Why is not projecting it onto this sample? So this is that, and now this projection, weirdly enough, let me see if this is working. So if I move these to, no, not that one, this one, the actual path. If I put it on top of the sphere, will you project on top of the sphere? Maybe that sphere doesn't have collisions, but it does because this world ray hit query is actually detecting these because these is actually working. But these, why is not working? If it is, the exact same, maybe I need to regenerate the thing again, clean up, regenerate. All right, let me think just a moment. Why is not actually projecting these down correctly? Neither, not the spline sampler. Oh, there is an actual project into surface. All right, let me try this. So I'm going to stop this one and start this one. Where was that? Oh, no, it's not here. It's in the actual spline projection. So, all right, now it's up here. And what if I turn on project onto surface? Not doing that. Maybe if I grab the actual zone and I intersect it with the sphere, still not doing it. Hmm. What if I now, um, no, it's not projecting. It is actually projecting down. Um, but for some reason, it's not detecting this sphere. Like, what is wrong with this sphere? Does it has collisions? It does. Block all. Hmm. All right, let's get rid of that. What if I grab these and create a copy and I put it like that and I regenerate the PCG? So it will project, but won't at the same time. I don't know what is going on here. God, look at this. Oh, project rotations? No. All right, let's do something. For today, this thing is just going to be projecting on a flat surface. Tomorrow, I'm going to be debugging this thing until I make it work to my will as I really want it to work. Um, because, that is how it should actually work. And I'm going to teach you how, to actually fix these small issues here and there. So far, this thing should be working. So I'm going to leave the actual projection nodes and everything because they're kind of work, but it's not working, completely well. So this is what we got in the end. So we can have both our zone, right, not flush with the actual ground, and it's still projecting down. And the same is happening with the original source because of the world rate here query. It's actually doing the projection down, and that is also very good. And we have the difference node, which is making our path work here, and that is also really good. Now, um, do these things still works? Actually, changing the width of a path? Yeah, that is also working. So far so good. We have our path and we have everything together. Now, you can see that this starts getting a little bit out of hand with all the different PCGs everywhere. Sorry, all the different nodes and everywhere. So what you might want to do is actually separate them and in different. I think this is everything about. Yeah, we wanted to create a zone and an actual path. So I think so far we're covering everything. So what I want to do now is to start creating self-contained PCGs. Right. So let's actually do that. Um, let's create from here. Let's save everything. We're going to be separating this thing a little bit because, we might want to reuse part of these, but in a different order, right? So let's actually um, create another PCG like that. And in this case, this is going to be called, yeah, why not? The zone PCG. Oh, it cannot be zone. So, oh, yeah, it is going to be PCG underscore zone, right? And let's save it. Let's open it up. And now we have an empty. And we're going to be using now these input and output, all right? So for this zone, we're not going to need an actual input, but we're going to need the actual output. So let's put that down there. And what we're going to do is actually copy everything about the actual zone, right? And that is, the actual get of the spline data, the projection down, the spline sample that is happening, on the interior. This is the mask, right? Up to the actual intersection. Oh, we are going to need an actual input. Yeah, that's right. So we're going to be copying this and we're going to be pasting it down here. And what we want now is to have information in and information out. And that is going to be this, right? So in our information in is going to be whatever comes into the intersection, right? And what comes out is what is going to be the actual math out of this. So this is going to be doing the exact same thing. It's going to get a spline that has the zone tag for the actor, the zone tag for the component. Then it's going to be projecting it down to whatever shape this thing have. And then you're going to be intersecting it to another PCG graph. So these on its own, now it's, self-contained. And now the nice thing about this is that instead of having all these, nodes here, we can actually add our PCG zone, uh, create PCG zone subgraph node. And you can see that this thing has an in and an out. Um, so what you want out of this is connect your initial sampler into the in. And now this already is going to have I'm going to stop debugging this so you know what is happening. So we have this sample, right? And what we get out of this PCG zone is, yeah, it's exactly that. it's actually the cutout of the zone. And now we can actually remove all of these unnecessary clutter from here. And now this thing is auto-contained into just one um, node. And we're going to be doing the same thing for the path, right? So let's save this PCG sample. And let's stop debugging this one and keep now debugging the end of it. So it keeps being the exact same, but now you have this PCG zone on one, particular thing. And I think we can also omit this. So if I go to my PCG zone, can I change the type of output that this thing is? Um, Label usage, loop feedback, allow type, point, warning. Let me connect this there. All right, now I'm going to have these inside here. But the difference now is that here we don't need this anymore. So this is going to connect. So you can actually set up what is going to be your output from here. So here in the output on the array, I actually set this up to be of the type point. So you can actually save this conversion from the intersection because the intersection actually, create a different type of output, but you can convert it before it goes out. And now it looks a little bit more cleaner on this side. So we're going to be doing the same thing for the path, right? So let's create a new PCG graph, and it's going to call PCG underscore path. Let's open it up. And we're going to be doing inputs and outputs also. I'm going to be grabbing all of this and copying it first. Let's put it here. And the input is going to be the, we miss something. We miss the actual difference node. So let me copy that and paste it here. So this is going to be in the difference, and the input is going to be in the source. And the output, we're going to change it already to be points. So instead of any, it's going to be points. Here we go. And we're going to be expanding this and connecting this to that. And it's going to create the translation node in between. But this is good. Let's save this. Let's go to our PCG sampler. We can get rid of all this. And instead, we're going to be using our path PCG and subgraph. And this is it. This is what we want. After the PCG zone, we don't need this difference anymore. We're going to be connecting these to that and these to that. And we don't even need this. This can be connected from point to point. And that's it. So now this is, a lot more organized, right? And I'm going to show you something incredible in a second. But now this thing is like this. Oh, very good. But now let's say that you want to change some particular about the PCG zone or the path, right? You can double click on it and it will take you and open the PCG on its own. So you can fix it here, you can save it, and then you can close it, and everything looks much better. So you can actually expand on, these density filters and the transform points. You can create your own math that happens inside this kind of thing with inputs and outputs, right? And not only you will maintain it a little bit more neatly, but also it's going to, allow you to reuse these different PCGs on other PCGs that you might be creating. So this is, the same as most things that we are teaching in this course is a labor of love. So your landscape, your landscape material is a labor of love because you're going to be making it better and better every time. Different tools that you can create with your blueprints, you're going to be improving them in time. And the same is going to happen with your PCGs. As soon as you start understanding, a little bit more about how it works, you want to make them better and better every time, right? So this is it. You can see that this thing works on its own. You don't need to do much. If you want to repeat this thing, we can actually grab our path, the PCG sampler, and the zone. We can delete that. And we can simply make sure now that we add our PCG sampler. The only thing that it's doing is actually doing the sampling out of this, right? So I can now make this bigger. And this is the only one that you can actually make bigger. And I don't know why this spline sampler doesn't do this. Do I still have this on here? I don't. So why does this thing looks like there is an actual this this is very weird. It's actually assuming that there is an actual zone blueprint here, but it's not. Are you sure? All right. I don't know what they are doing with this. So let me actually create this zone, which should actually. All right, now it's working. So I don't know why that thing was like burned in into the information of the PCG. It should actually do this. It should start like empty, right? That is what you would expect. Now it does some sort of, now that I think of it, and I may think that it might be because of optimization decisions that Epic is taking with PCGs. Like, all right, let's bake it a little bit, right? So it doesn't calculate every time you move something around. Maybe it's something like that. They're trying to make it better. But yeah, how it should work, it should be completely empty because you don't have an actual, zone on it. Now you can actually make it grow on a particular zone, which is great. And now you can add a path on top of it, and you can cut, you know, part of it, and that is pretty nice. Now, let's say that we want to add a little bit of um, things that you might want to grow inside the path, right? Because yeah, you have like a sampler from for the outside, and you want to have something growing on the inside of this. Maybe there's going to be pebbles, right? Or it's going to be something, right, that could be growing inside here. So let's do that. Let's actually open up our sampler, and we can work on the sample, and then later on, um, we can add, different PCGs to it. So let's do this. So we need to base ourselves into this particular path, right? So let me open it up because we may want to do another output, right? And this output, I'm going to be creating a new output from here. And this one is going to be, let's call these um, path. Yeah, let's call it path. So this output is going to be an actual path. The usage is going to be point, and that's it, right? So what I want out of this is not the difference. I want to have the actual mask out of these PCG because I want to use it to then generate, maybe, and in fact, I can do it inside here. That would be nice. So instead of connecting these already, I'm going to do my own difference with another sampling that I could be producing here. Let me show you what I want to do. So I'm going to do, no, this one is called sampler. This one should have the actual samples. So yeah, I'm going to be spitting this out here, and I'm going to be reusing it later on. All right, this is it. So now I have this path outside, and what this is going to be doing, if I create something like a transform point, I want you to see what I'm actually getting out. Not copy point, transform points. There we go. So if I actually take a look at this, sorry, it's the actual mask. This is what I want out of this. So what I'm going to do is I'm going to create another sample, right? Because this is the actual PCG that is doing all the sampling. But in this case, I don't want these to be, this big. I want this to be really, really small. Let's do something like 10, 10, and 10, right? And I need this to be maybe 10 also. So it's really, because I want to create pebbles in the center of this path. This is what I'm after, right? Um, so um, this is it, right? It's looking fine. But what I want to do is actually do this same path exclusion, but it's going to be an actual inclusion. Oh, I could also do this inside. I can actually move then that inside later on. So I'm going to do intersect. Intersect. And the primary is going to be this source that is a little bit more tight. And then the path is going to be cutting that. So now if I do these and I do this, yeah, this is what I want, right? So now, apart from cutting a path, now I have pebbles, right? But now the pebbles are, everywhere inside, and that might not be what I want. I might want to have them to the edge of these. So from the actual, I need now to make a distance calculation, right? From the center of these to the edge of these. So let's actually do distance to density. No, it's distance. There we go. And let me see how this works, because I may need to actually do this more than one time. No, this is not the one. Let me stop debugging this. So no, it's the other way around, maybe. Disconnect this. All right, this is gonna be the source. This is gonna be this. Now, yeah, set density. All right, here we go. So now you can see that I'm drawing nearer and nearer. So what I want is for these to be as close as I can to be on the edge, but it's still not on the edge. Mm. Center. All right, now all right, now it's working. So this is what I want. I want a black mask in the center of these, right? So what I want is now that I have this information, before I do the actual intersection, now that I have this information, I want to do a density filter where I can get rid of, can I, um, no, I think this is good. Yeah, this is good. Because then we're doing the intersection later on. I was trying to see if I could, invert it, but this is all right. What I want out of these is now to do a density filter, right? So I need to density filter, and I want to get rid of everything that is um, that has no value in the center. I need to actually stop debugging this and start debugging this one. So is this the thing? Yeah. I need to keep this on and on and on until around maybe there, right? I can tweak this later. And now I want to connect these to be on top of this. Now you're going to see the magic here. This is what I want. I want, rocks at the edge of the path, right? And not in the center. And yeah, it is this simple. And I can keep playing with this density filter until I just get, the edge to have, a few rocks. And I now can, do things like the transfer points, right? Let me put this there, copy these, paste it there. And I'm going to stop looking at this and looking at this. So now they're going to be having like random rotations on them. So now let's practice with the few minutes that we have left. Let's actually do a little bit of a packing of this. So let's think about this. So the actual sampler should stay here. And I will be spitting out the difference between this entry and this entry, but also I'm going to be spitting out the um, the mask, right? So what I want with this is to have an input, which is going to be the source, and another input that is going to be the mask, and that is going to give us the actual out. So yeah, I think that is what we need to do. So let me actually create, save everything first of all. Here we go. And I'm going to be creating a new PCG graph that is going to be called um, path sample, maybe, or path. It should be part um, of the path. Yeah, let's actually add it to the path. I think it's going to be the best. So yeah, delete this. Let's open the path and make it part of this one. So all we need to do from this one is let's copy everything up to the intersection. These, let's integrate this into this path. So what we get here is this result. Before we do the difference, we're going to get into this source, all right? And then we need to add another input, which is going to be the, all right, this is also going to be the target here, if I'm not mistaken. That's right. And the only other thing that we need to do is do another input, and that is going to be connected here. So this is going to be, instead of in, let's set these to be um, um, zone sample, right? And these second, the other one that we're going to do, this is the path sample. Path sample. And again, this one is going to be point type. And that is good. Now, this path sample um, needs to be in this source right here. And we're going to have, yeah, we're going to have a new exit out. That is going to be this path right here. And this is it. So now let's see if this is actually working. So we should have a path here, but now we have a new path sample. And that is the only thing that we need to connect here. And the exit of this will have the intersection in already. Yeah. So that means that that can be connected right out to the transform point, just like that. Oh, but we do have the actual density filter inside here. Can I have that afterwards? I think so. All right, let's test it like this and see if it's working. It is. So the only thing that I want is to actually extract the density filter. And I think that that can actually be done outside. Let me see if that is the fact. So instead of doing the density filter here, this is going to be connected to the primary source like that, right? And the density filter now is going to be outside because I'm already getting the, you know, this information of the distance outside. I think so. So let me cut this and paste it outside of this, the same as we did before. And now, yep, we can do that exactly on the outside. All right, this is very good. And now we could, add our, static meshes. Let's do these. That's right. Now the only thing that we need is to save before we actually play with the mesh spawner, which kind of crashes sometimes. Let's add a new one, static mesh spawner. And from here, we're going to spawn pebbles or rocks. And let's go down here, mesh entries. Let's create a new one. Let's go down here and let's do rocks. Tomorrow we're gonna get and it crash. Tomorrow we're gonna get an easier way of actually doing exactly that. Mostly because it's very buggy. But the other thing good about this is that we're gonna be able to change the actual mesh that you want to be exponent from outside the PCG, which will make it like perfect in that sense. All right. So we're here. Yeah. Open it up. Let's go to our PCG map. And yeah, open it up. Good. The PCG path is good as it is. Now it's this thing here. And we need one of these. So let's do static mesh spawner. Let's save it. Let's open a new mesh entry. And we're going to be very careful about this. Save everything. Let's look for a rock in my content. This is from the kite demo. No, I don't want to play with that. Let me look for a small rock. I'm scared of actually searching rock here. Rock? It worked. All right. We're good. So maybe these pebbles might do. So let's actually select this and now assign it. And yeah, of course, you're going to have a warning. That's good. Now let's see. Oh, where is? And the map? Oh, wait. Oh, all right. So we might want to transform those points from 0.01 to zero point zero 0.01. What about now? Oh, there it is. So this is unavoidable. You know, the end. We might want to create some way of actually don't allow these pebbles to grow here. But at least on the center of the path, those are going to look perfect. The nicest thing about this is that, yeah, this is fully, let me actually see if I can find one of the control points of these. Here is one. So now I can move these to the left, to the right, to the left, to the right. This is how PCG is supposed to happen, like instantly. You should be moving things around and everything should be very snappy. And here it is. I have a path with a couple of rocks, growing to the side, and I have a small forest, happening in no time. All right. I think I cover everything that I wanted to cover, and on this class. Next class is gonna be assigning parameters. So we should be able to select our PCG from outside here. And you should be able to actually assign the different mesh entities that you want in and also play with the densities of the actual sample so you can have more or less, um, trees and all that stuff from right here. So that is what we're going to be doing tomorrow with PCGs. All right. Are you enjoying PCGs? You find them, useful at all? I found them fascinating.
I s-
I actually couldn't get them working the last time, so I'm gonna go over them. Uh, yeah, when you upload and just make sure it's solid. I can't figure out how to use it in my scene.
All right, all right. So for many things like coral and all that kind of stuff, maybe you want to have like creating paths that you can actually draw a path, or maybe like one of the skirt of your landscape, and that thing is going to be creating, a path of corals that you can create that way, very easy, very fast. Or if you need to actually figure out a way of not showing the contact between your landscape and a huge rock or something, you can add like a PCG that is full of rocks, right? And you can actually put it there and draw a line, right, a spline, and that will grow a couple of rocks, right, that are going to be there pretty easy, instead of going painfully and putting them or having to go and, paint them. Um, you can create something like this, right, to put in front of that connection so you can actually hide it. Or as we did before, on these trees that are awfully, connected to the ground like this, you could put some bushes around each and every one of those um, samples, right, to hide the actual connection. So they are useful like that.
Cool.
All right. So I'm going to be checking out the issue with the projection because that thing is really important for these to actually work anywhere and not only on flat surfaces. Um, that being said, let's actually test this, right? Let's see if that is the actual case because I'm worried. So I'm going to create this, that, and the zone also. Yeah, that be gone. The floor can be go off. Let's create a small fast landscape like that. And let's create a blueprint brush with material only. And let's click right here in the middle. So we have, and
Yeah,
shake it. Right.
I was gonna
No,
say
so
that
go ahead.
I think PCGs could turn into like a specialty, meaning
Yeah, very soon.
like you I'm intrigued by them, and it's like, oh wow. I mean, I've seen more videos of artists that are just making pretty landscapes. And then there's the thought of like, yeah, but like what, and you've talked about this through the course. It's like, yeah, but what if the art director wants that moved?
Mm-hmm.
So I was wondering, can you, once you're like, let's say you've built a scene, it's all PCGs, can you bake it
Yeah.
down to, oh, you can. Oh, okay,
Yeah,
cool.
there is
Cool.
in 5.4 or 5.5, they actually
Yeah.
added a node that
Yeah.
will bake it out. It's gonna be
Okay.
um, like once it's there, you can do like a clean PCG link, and
Uh-huh.
that is gonna spell them out. And the link between the meshes and the PCG is gonna be severed, and
Okay.
they're gonna be, I'm guessing, an ism. So it's gonna let out like an actor with them in, and
Yeah.
then you can jump in and actually move them around if need to.
All right, cool. Because that was not to say my reluctance to like fall in love with these.
Right.
Um, and I assume that was there. I just didn't, you know, again, I didn't know. So, but
Yeah, I was.
watching some of these videos from last week, and I was going through my history today to refine them.
Hmm.
And these guys are making these just beautiful like paintings of
Hmm.
like rolling hills. It's just like you did that in an hour. Like it's so cool.
Right. That's right. So I'm not mistaken. This world rate heat query is actually working because you can see the samples, you know, revealed by this world heat query actually projecting down. But I don't know why the PCG zones, so the ones that come from the spline sampler, um, are not actually being projected down. Like I can actually see them up there. So the next thing that I would want is for them to be projected down. And that is not happening. I don't know why this is not actually projecting down this information. So the information keeps up there, but it's not actually doing this. I remember that there is this project into surface stuff. It's not doing it. Like sample points, project sample points into one possible surface given by the spline boundary. So this is the spline boundary. Select multiple. Maybe there's something here in advance. Nope. Must overlap self. What if I grab this zone and overlap it with the landscape just a tad? No, it's going through it, but it's not projecting it. I have no idea. So this is what I'm going to be fixing today. And I'm going to let you know how these should work. Again, these work 100% one version prior to this one. So yeah, this is not projecting down. All right, not to worry. I'm going to fix this. And for tomorrow, you're going to see the result of how to fix this projection down, because it should work. All right. So
Okay.
that's going to be it. So today we're going to have an office hours. So today we can look a little bit about animation. Is that good?
Yeah, that's great. Thank
All
you.
right. Let's do it. So you want like motion design animation, or you want camera animation, or you want character animation?
No, I can do the camera animation and everything already. It's the how do I bring a spline in for something like the sharks? How do I
Oh,
attach that to the mesh? How do I,
oh, all right. All right. Let's do that. All right.
yeah,
That's great.
I have a little bit of experience, not with making the rigs, but with actually rigging and doing a bit of animation, but I'm not sure how to do that with it.
All right. Let's do that. That is going to be an amazing class. So let's do that today. It's going to
Okay.
be at 7 or 8. Oh, sorry, at 6 or 7 Toronto
Um,
time.
Probably later would be better for me. So probably 7. Is
What
that
about you,
okay?
Matt?
I'm good. I'm good with that time.
All right. So let's do 7.
Yeah, 7. Okay.
Perfect.
Sounds good.
All right. I'm going to stop the recording.